Hi everyone, my name is Tiong So Hong. In this video, I will demonstrate the simulation on the harmonic analysis in multi-level inverter using the hybrid PWM technique. First of all, to perform the simulation, I was using the MATLAB software with the version of R2015A. And the modeling of the multi-level inverter that I have been used was created using the Simulink model. Since I was already created the Simulink model, so I will just open it from my file. So after we open the file at the MATLAB, we will find our work and will add our saved folder. I will show or demonstrate only two of the type that have been performed from two of the method of the switching technique, which is the first I will show on the PSPD PWM. So in this PSPD PWM, for the modeling of the hybrid, it all is the same. The differences is only here, only in this repeating sequence, which represent the carrier waveform or the carrier signal to the multi-level inverter. And the IGBT diode here, since my level is I only use the 5 levels, so I will only consist the add switching diode or switching device here. So if the difference level will have different number of the switching diode here, and also there it will different in number of the repeating sequence. So since our only 5 levels, so I will only have 4 repeating sequence of 4 carrier signal that inject to the system. First, we will have to design or set the modulation index, which is the amplitude of the sine wave, to 0.9. After getting the suggestion from my SV, she suggests me to put that 0.9 as the value to get the more accurate output. And here the frequency, we use 2 pi 50, which is the 50 is 50 Hertz, because the unit they use in this system is radian per second, so we insert the 2 pi 50. So we will set our phase and the sample time f0. And then next, our power GUI here, we are set it as a 1 microsecond, which is also I get it from the suggestion from my SV. And next, we set our repeating sequence. In this repeating sequence, we are setting the time value, and actually this 2000 is the carrier frequency that fixed for all type. I will not change the frequency here, but I will change the frequency band. The frequency band here, like this, I will change the frequency band here to make the differences at every type of the method that have been created. So here is I set the frequency or the time of the triangular shape to make it become narrow frequency band. Since we have finished the demonstrate for the PSPD PWM, so next I will show the variable carrier frequency band modeling, switching technique modeling, PD POD. I will demonstrate the PD POD modeling, and it's the same as the modeling as the PSPD. The setting for the sine wave is also the same. The amplitude is 0.9 and bias is 0. Our frequency is 2 pi 50. Our phase is 0. Then we did not change the IGBT or the diode setting parameters. And next, we set the relational operator is greater or equal for all. And then the discrete or in this power GUI, our sample time is also 1 microsecond. And then for the load, we also maintain the same, which the inductance is 9.1159 millihenry. Our capacitor is 0.6947 microfarad. and our resistance is 81 ohm. So for this variable frequency carrier frequency band switching technique, we are setting the triangular carrier signal that inject to the system, to inject to the model link, will be hybrided with the low carrier frequency band and the high frequency band, which the low frequency band is wider triangular, and for high frequency band is the narrow triangular carrier. So the output of the triangular will become like this. So here the yellow one is the sine wave, input sine wave that we are set. So we can see here, this one is the PD PWM, and which is much wider than the POD PWM. So next we see the output 5 level. We can see here it was same with the previous PSPD PWM, did not change much. And here is our output current and voltage. Here is the hybrid of current and voltage, and the current is also 2 plus ampere, and the voltage is 180 volt. And here is our FFT analysis, which is to show the harmonic value. In this method, the generated harmonic value is 1.72%, which the starting time is also 0.02, number of cycle is 1, its fundamental 50 Hz, and the max frequency is also the same. So that's all for my demonstration of simulation. Thank you for listening.